Okay, so let's talk a little bit about this whole structure. Um, we're in Cadence, and let's just go first to the library manager. So we're in the QUIF directory, home dparent QUIF, and there's several directories in there. We have QUIF, and we have QUIF readback, um, and so let me start with this so that we can understand what QUIF readback is. So here's all the high level, multipliers with a multiplier. So I have a multiplier, extracted layout schematic symbol, and then you have two multiplier underscore test bench. So the underscore test bench is always added to whatever it is you happen to be testing, and that's our convention. Um, now, to look at the pad frame, okay, it's only layout, and in this view you can see all these pads. And if you want to change a pad, you just click on it, press Q, and type in a different name of the pad, and then it automatically lines up. Because if you move anything, you could short your VDDs and your grounds and all that. So you never ever want to move one of these. You just say, oh, you know what? Because we talked about adding the ESD, right? So pad A ref, I believe, has no ESD. Pad analog ref has no ESD. So if we wanted to add it, we change the name of the cell to the one that has the ESD. And there's a document I have to find to show you what each one of those means. But thou shalt never move any of these things, because it might be a little bit easier if I turn on the let's see, view display. Oh God, it's been a long time. Hey, where do you turn on the number of views that you layers? Is it? No, the number of cells. That's what I want to look. Design, open hierarchy. No. That's well. I can go descend edit, or let's just say descend read, and now you can see. So yeah, I mean, well, you didn't probably. So if you look in here, are these big. Yeah, I mean it's. And in order to get it to fit, they will have broken rules here and there, and that's why, not everything. And um, there's no symbol, there's no schematic, but um, that can be created. And since we have a little bit ahead, oh, then design hierarchy, you can just return. Okay. But man, I cannot remember how to turn on the number options display. Oh, that's what you were saying, wasn't it? Where is it? Levels. Now we can see everything. Or should. Options display. Did I? Oh. Yeah, there we go. All right. So now we can see everything. Now, right now, let's say I'll zoom in. It's not too bad, right? The screen refresh rate, it's fine. The trouble kind of occurs is if I put a part, let's say it's here, and I need to draw a line right to this spot. You can see now you can sometimes overlap, and let's say this looks like metal 2. I know this colors are probably different than what you're used to, but that this tells you what everything is. All right. So yeah, you can if you're connecting a metal 2 here, that's not too bad. You can go over a little bit. But if I went over too far, well then I'll be shorting here. So you have to kind of this is where the hard part is. You start here, and in order to connect to this part, you're zoomed in as far as you can. Then you have to draw this wire all the way over here, then zoom in as far as you can. And so it can get slow. Now this has all been done, but I did think that there was some spots that maybe if he had spread the wires out more and that goober happened, maybe it still would have worked. And so that's something to think about. But this pad frame is supplied by MOSIS. They did it in Tanner tools. And, in general, the pads pretty much work, although I have had trouble with the bidirectional pad. Anyway, so you can you can run DRC and it will come up with a lot of errors. All right. Now here, yeah, I did actually make a symbol, okay, and it's what I do is I make, and this is for the big test bench. All right, this is like the chip. So if I go to Quiff Top, that's how I name everything. That's the thing that gets kind of sent out. All right, and there should be a test bench. So this would be the whole chip. Okay, so there should be 40 pins here. Right, and what I do is I make a schematic with all these ports. And then I do create symbol from schematic, and then I delete that schematic because it'll cause errors. But notice, VDD is not global anymore. It's got to be a real, hard wire. And so this test bench would be for the whole chip. Now, yep, it runs really slowly. It's running off of the extracted. We kind of run it to make sure that the signals are doing what they're supposed to be doing. But you're just making sure that it's all kind of connected. So yeah, right. So yeah, transient. Yeah. So yeah, now you can descend design hierarchy, descend edit should give me a choice. So there's an extracted layout. We'll go into layout, right? And so there's the whole thing. All right. And these extra bits that we've added are in CMP. It has to polish these things flat, and if it's kind of rough, the polishing pad will make the wires different sizes. So you put on these kind of things wherever you can. We slide something in. But yeah, we even have kind of a Spartan symbol, SJSU, and this is where the anomaly was. And I thought, oh yeah, it's right in here. And I thought maybe we could move these wires around, but it doesn't look it. It's tight. We're running out of room because we've got 4 of these. So, it's got 3 metal layers. We have 3, right? But anyway, so this whole thing, and then you design hierarchy, return. So again, this is what I call a pin-to-pin simulation. You can't design with this. You're just verifying because it would take too long. And yeah, we want to find out what's the smallest VDD we can get away with, sure, but we wouldn't do it on this. We would do it on just one quiff, and we would probably just do it on a schematic to see, hey, can we do 2.5 volts? Can we do that? And so this quiff top, or wherever, quiff final, quiff top final back. I'll have to find it. That data gets translated to a different format and sent to MOSIS, but sometimes that translation gets screwed up. So what I do is I translate it out and I read it back in. And there should be quiff Padframe 2. That would be the high level thing. And then you can see that it is right. And if you're feeling really paranoid, you can copy the whole test bench, re-extract this. But basically, you can tell if a layer. Then what I do is I check for missing layers. Like one time the contacts weren't there, and the whole chip failed. So what I do is I turn each layer on and make sure that every single layer is there, just to make sure that it's right. So with all those things, that's why I'm pretty confident everything will work this time. Because his chip worked. It was their fault in the end that all of the devices didn't work. So I think our design flow is pretty good. It's just with that LVS and extraction, it would speed things up. But I think that's the big thing. Everything's in here. Everything has a test bench. And so what we would do is there's a pad frame. Where is it? That's the 1.5 micron pad frame. Okay. That was we used that the first design we ever did. The
Padframe is just where MOSIS gives it to you and they bond to those.
Right here, yeah, right in there. What I'm trying to do is where's that part located? Oh, okay, it's an AMI6. Oh, okay. So all these parts, right, are in fact here. All right. And it's got more than, so there's pad IO, right? And I forget what that is. But what we can do is add things here, and then just like we make a symbol, we make a schematic, we make that. And then because if you could do LVS, it would really save a lot of simulation time because you would know whether you connected it right or. So that LVS, it doesn't seem like a big deal when you're doing a NAND gate, but probably as your project got bigger in 166, you realize how important it is. I think that's it. Bless you. Let's stop.